Year 12 Summer Assessment, Paper 1. We are going to work through each of the questions from Paper 1 of the Year 12 Summer Assessment. So question 1 is a very simple sequences question to warm up with, and it's getting you to make sure that you understand the difference between different types of sequences and that you know the correct vocabulary. So which of these sequences is periodic? You can see it's sequence C. It has a period of what appears to be 3 as it repeats after every 3 terms, 20, 5, 1. 2. Which of these sequences is convergent? Well, that's sequence B. Sequence A is clearly divergent. And then the last part, find in terms of n the nth term of sequence A. So sequence A, the first thing to make sure we understand, is a geometric progression. It has a first term of 1 and it has a common ratio of 2. And you need to remember that the nth term of a geometric sequence is AR to the n minus 1. So that's 1 multiplied by 2 to the n minus 1, which gives you an nth term of 2 to the n minus 1. Question 2 is really all about understanding sigma notation, or the summation notation you have here. And it's telling you to add up all of the cube numbers between 2 cubed and 5 cubed. So you start with k equals 2, so 2 cubed, you then go up 1 to 3 cubed, then 4 cubed, and then you stop at 5 cubed because you can see the 5 up here as the upper limit. You then just need to work these out and add them together and you get an answer of 224. Question 3, part 1. Now there are lots of different ways in which you can do this question. 10 to the power x equals 316. A lot of people will do x is equal to log to the base 10 of 316. That's the simplest way of doing this question, and then you can just use the log button on your calculator to work this out, and you get 2.4996, etc. The answer is required to 3 significant figures, so that's 2.50 to 3SF. Part 2 is testing whether you understand your logarithm rules. So we start with log to the base a of a squared minus 4 log to the base a of 1 over a. We can rewrite this using logarithm rules. Log of a, base a, subtract 4 log to the base a, and then I'm going to rewrite 1 over a as a to the negative 1. Now this means the second term here, I can bring the power of negative 1 out as a factor in the front, which means that we get plus 4 log to the base a of a. Now 2 log a plus 4 log a is 6 log to the base a of a, but what we need to remember is that log to the base a of a is 1, so the answer is 6 at the end. There are multiple ways of reaching this final answer. Remember, it's all about getting to this via any correct use of logarithms. So question 4, we hit a multipartite question. So for part 1, you've got to sketch the function for the domain. Now you have access to a graphical calculator, so you've got the use of that as well. Don't forget that. Make sure when it asks for coordinates that you give coordinates and not just a single value on a y or x intercept without showing the full coordinates. So the graph of y equals 2e to the x minus 3 looks a little bit like this. So there is y equals f of x. It actually has an asymptote along here at y equals negative 3, although you weren't required to provide that in the question. Now, it does say that we are sketching the function for the given domain, which is x is greater than or equal to 0. So in actual fact, we shouldn't really have anything after x equals 0. So I'm actually going to remove this asymptote here and just have this section of the graph. Now, let's label the intercepts. So here, x is equal to 0 and y is equal to -1. Now here, to find that point there, we need to set y equal to 0. So if y equals 0, this gives me 2e to the x minus 3 equals 0. E to the x equals 3 over 2. X is equal to ln of 3 over 2. So to write out the full coordinate, I want to write out ln 3 over 2, comma 0. I don't want to put in a decimal value for ln 3 over 2. I want to give the exact coordinate here. Now, what is the range of the function for part 2? Well, look at the y-axis, and can you see that we're allowing any y value from -1 upwards for the yellow curve, y equals f of x. So the range is that y is greater than or equal to -1. Now, part 3, the inverse function. So I'm going to set y equal to 2e to the x subtract 3. Let's swap over x and y. So we get x equals 2e to the y minus 3. And then, of course, we need to change the subject of this to the form y equals. So x plus 3 equals 2e to the y. X plus 3 over 2 equals e to the y. And this then gives me y equals ln brackets x plus 3 over 2. And this is the inverse function, y equals f minus 1x. Now, we need to identify the domain and range of this function. So what I like to do is to think about the function and the inverse together and then swap over the domain and the range. So f of x has a domain of x greater than or equal to 0 and a range, we were asked to find it, of y greater than or equal to -1. So the inverse function will have a domain which is x is greater than or equal to -1, and it will have a range of y is greater than or equal to 0. So in answer to part 3, the domain is x is greater than or equal to -1, and the range y is greater than or equal to 0. Now, sketching the inverse function. So the first thing that I might do is draw the line y equals x, because we know the inverse function will be a reflection of y equals x in this line here. So y equals x. Again, remember you have a graphical calculator, so you can sketch this function here, the inverse function, and have a look at its shape. So from the axes, we know that the coordinates are reflected, so 0 minus 1 is going to become -1, 0 on the inverse function, and ln 3 over 2, 0 is going to become 0 ln 3 over 2 on the y-axis. And our graph is going to look like this. And you can see that in pink here, y equals f minus 1x. Look at my labelling. I've labelled both graphs. I've labelled the line y equals x. The function and its inverse intersect here on the line y equals x, which they should. And remember, the coordinates are reflected from f of x to create f minus 1x. So look at the yellow and pink coordinates and see how they've been reflected in the line y equals x. Question 5 takes us on to some work on sequences. So we're given an iterative formula here, or a recursion formula. A1 equals 4, and you then have to use the recursion formula to work out A2. So remember, this is telling us that the new term, AR plus 1, is the old term, AR plus 3. So A2 is equal to 7, A3 is equal to 10, and A4 is equal to 13. And those are the first 4 terms of sequence. Now, if we want to give another one after this one, if we wish, we could give A5 as well, but it does ask for the first 4 terms, and I think this is sufficient. Now, find the sum of the first 100 terms of the sequence. So we are looking for Sn. We can use the formula, a half n 2a plus n minus 1 multiplied by d, the common difference. So what do we have here? We know that the first term a is equal to 4, the common difference d is equal to 3, and we're adding together 100 terms. So S100 is equal to half multiplied by 100 multiplied by 2a, which is 8, n minus 1, which is 99, multiplied by d, which is 3, and we input this into our calculator. So what does that give us? It gives us 15,250. Now, this is a question where they ask us to show detailed reasoning because it would be, in theory, feasible for somebody to work out 100 terms of the sequence and then manually add them together on a calculator. It would be a phenomenal waste of time, and it also doesn't show a very sophisticated understanding of mathematics. So that is included in the question to make sure that people understand and use this formula for the sum of n terms. Question 6, a geometric progression this time. So what do we know? We know the first term a is 8. We can see that the common ratio here is a half. Now find the 20th term. So un is equal to a r to the n minus 1. So u20 is equal to 8 multiplied by a half to the power of n minus 1. And of course n is equal to 20, so this is 19. Now, the answer has to be expressed as a power of 2, so we're going to rewrite each part of this as a power of 2. 8 becomes 2 cubed, and then inside the bracket I write a half as 2 to the negative 1, and then 19 as the secondary power here. So this is 2 cubed multiplied by 2 to the negative 19, which becomes 2 to the power of negative 16. There are other ways of reaching this answer, but this is a nice, efficient technique. Now, the sum to infinity exists because r lies between 1 and negative 1, which means that the sequence converges. You need to know the sum to infinity formula, S infinity equals a over 1 minus r, and this is equal to 8 over 1 subtract a half, so the sum to infinity is simply 16. Now, question 7 is another question that requires us to show detailed reasoning in our answer to the question. Why is that? Because in theory, you could plot this on a graphical calculator and read off some values, not showing a real understanding of the mathematics involved. So those of you who did not sketch a graph for this will have found you did not pick up all of the marks in this question. So my first job is to sketch a clear graph of this modulus function. Now, by all means, use your graphical calculator to help you draw the sketch if you're not sure about it, but you must then show the correct mathematics that you have used here, particularly because of the wording, show detailed reasoning in your answer to the question. So let's set up our axes. Now, if we were drawing the graph of 3x minus 2, that would simply be a straight line like this with a gradient of 2 and a y-intercept of negative 2. We are drawing y equals mod 3x minus 2, so I want this portion of the graph here, and I then want to reflect the portion that's negative up like that, reflecting the x-axis. So let's get rid of that. And I'm just simply going to write y equals mod 3x minus 2 over here. Now, I'm then going to draw the graph of y equals x, which is simply a straight line through the origin like this, which intersects my modulus graph at 2 points. Y equals x will be less steep than the modulus function because the two parts of the modulus function have a gradient of magnitude 3, which means both parts are steeper. So, solving the equation, we need to find these 2 points of intersection P and Q. So I want to be very clear about what's going on. So at the point Q, the green graph is 3x minus 2. You can see that. It would have a y-intercept of negative 2 if we carried it on downwards like that. Now that's equal to the blue graph, which is x. And if we solve this, we get 2x is equal to 2, x is equal to 1. So at Q, x is equal to 1. Now, I'm not being asked to find coordinates of points of intersection. It just says solve the equation here. So I'm not going to find a y-coordinate because I haven't actually been asked to do that. I've been asked to find x values. At point P, the green graph is now negative 3x plus 2. look at its y-intercept. It's going to be a positive 2 here, reflected up from a negative 2. And look at the gradient, look at the direction of the line. It's a gradient that's negative, so it's a negative 3. So negative 3x plus 2 is equal to x. And when we rearrange this equation, we will get 4x is equal to 2, so x is equal to a half. So the two answers to this question are x equals a half and x is equal to 1. Question 8, a slightly different logarithms question. We have a graph of log 10y against x, a straight line. So find the equation for log 10y in terms of x. This is basically all about finding the equation of a straight line. Now, the two things that you need to know are the gradient and the y-intercept. So the gradient we can calculate if we use the coordinates here. I'll just write in that the y-intercept is 0, 3. So change in y, 5 minus 3, over change in x, 4 minus 0, gives me a gradient which is equal to 1/2. Now my y-intercept is equal to 3, which means in theory this equation is y equals a half x plus 3. But the y-axis isn't just y. The y-axis is represented by log 10y. So in place of y, I have log to the base 10 of y. The x-axis is simply x, so that's a half x plus 3, and that is the equation of the line. Now part 2, find an equation for y in terms of x. We need to raise both sides to the power of 10, which will cancel out log to the base 10 on the left-hand side. On the right-hand side, we'll have 10 to the power of a half x plus 3, and you are absolutely allowed to leave your answer in this format here. I know some people did this, 10 to the half x multiplied by 10 to the power 3, because of course you would add the indices, and that then gives you 1,000 for 10 to the 3 multiplied by 10 to the half x, which is a slightly different version of the answer. I'm not sure it's any simpler though. Question 9. We have a graph where the equation of the curve is y equals root of 1 minus 9x squared, and we've got to find the value of a, which is reflected to give a value of negative a on the other side. So part 1, we know that at these 2 points, these x-intercepts, y is equal to 0, or f of x is equal to 0. So 0 equals root of 1 minus 9x squared. Square both sides. Rearrange. 9x squared equals 1. X squared equals 1/9. X is equal to plus or minus the root of 1/9, which is plus or minus a third. But this means that this value here is a third and this value here is negative a third, so we must present just one value for a, which is 1/3. Now, part 2, the range of f of x. To get the range, look at the y-axis, look at the possible y values. They range from a y value of 0 to a y value up over here. Now, to work out this y value, substitute in x equals 0, and you will find y is equal to the root of 1 minus 0, or 1, so that's a y value of 1. Now, that means that the range of the function is that y runs between 0 and 1 inclusive. Now, for part 3, we have to sketch the curve y equals f of x over 3 minus 1. So I would like to do this by thinking about the two transformations that are taking place here. So the first transformation here involves a stretch in the x direction, and it's a scale factor of 1 over 3, so it's a scale factor of 3. So this means the x-coordinates multiply by 3 and the y-coordinates stay the same. So if I were going to sketch this as an intermediate step, it would look like this. So all of the x-coordinates would multiply by 3, the y-coordinates would stay the same. So that point there, which is 1 over 3 on the x-axis, would become 1. So we'd stretch out over here to 1. This point here, which is at negative a third, would multiply by 3 to give me negative 1. So I'd get a stretch like that. Now, this point here on the y-axis would remain at 0, 1, because 0 times 3 is still 0, and the y-coordinates are not changing. Now, the next part of this over here is a -1, which means that's a translation with a vector 0, -1. We're moving down by 1. So this blue graph I sketched is y equals f of x over 3. And what I'm now going to do in a very small amount of space that I have left over is to sketch the function y equals f of x over 3 minus 1. So I'm going to take my blue sketched graph and I'm going to translate it by 1 unit downwards. Now, can you see that y-intercept? It's on 0, 1. If you move it 1 unit downwards, it's going to end up at 0. So the graph will look like this. So it will pass through the origin 0, 0. Now we should label these coordinates here. So this coordinate here is translated down 1 unit, so it becomes -1, -1. Same over here, this one becomes 1, -1, and we are done. So think about how transformations can help you work out what this sketch actually looks like. Question 10. Given that f of x equals x plus 1 over x minus 1, show that f of x is equal to x. So that's a composite function where we apply f of x twice in succession. So this is f of x. So it's f applied to x plus 1 over x minus 1. Now, stop and think. What does f tell you to do in words? It tells you to take the input and add 1 to it, and divide by the same input, but subtract 1. And we've now got to deal with quite a complex set of algebra here, some algebraic fractions. So what I would like to do is separate this into two calculations. So it's x plus 1 over x minus 1 plus 1. That's the numerator. And that's being divided by a denominator of x plus 1 over x minus 1, subtract 1. Now, let's look at the pink part, which is here. It's the numerator. Let's give everything a common denominator. So x plus 1 plus, I'm going to cross multiply up over here, x minus 1 all over x minus 1. We'll deal with simplifying that in a second. And the second one, we'll do the same thing, cross multiply this over here. So we get x plus 1 minus, and because of the minus, you need to do this. Put the x minus 1 there in a bracket. You've got to be careful. So all I've done is separately give the numerator and the denominator of the original fraction common denominators in each part. And then with the numerator, the pink part, remember the denominator is this blue part here, the numerator, look at that, that simplifies to 2x over x minus 1 divided by, and we end up with 2 over x minus 1. Now what happens when you, and I'll move up over here for clarity, what happens when you divide one fraction by another? We multiply by the reciprocal, like that. And you can see here we get a solid cancellation there. 2x divided by 2 leaves us with an answer of x to finish off with. Now, hence write down the inverse function f minus 1x. Now, a lot of you went through the whole process of algebra of finding the inverse function, but you don't have to do that. Use this fact here. We know if you apply a function and its inverse in either order, like this, you always get back to x. So you can either apply the function and then the inverse, or apply the inverse and then the original function. Here, we've applied the function twice and got back to x, which means that f minus 1 of x must just equal f of x. It must just equal x plus 1 over x minus 1. And you can go through the algebraic steps to do this, but there's no need. You should really understand that if you apply the function and then apply the function again, you get back to the beginning. That means that the function is self-inversing, okay? It means that to get back to the beginning, you just apply the original function again. Now this means that the function must be symmetrical in the line y equals x, because remember, an inverse function and the original function are reflections of each other in the line y equals x. If the function is its own inverse, there's only one graph, and that graph must be symmetrical in the line y equals x. So because it's self-inverse, it must be symmetrical in the line y equals x. And a good example of this is the function 1 over x, y equals 1 over x. Draw it, have a look at it. It's a self-inverse function and it's symmetrical in the line y equals x. Question 11. There's a lot to do here in this last question. Make sure you've read it very carefully. Okay, 3 minutes after the drink is made, show that the difference in temperature is 43.0 to 3 significant figures. So D is equal to the starting temperature, or the starting difference, which is 45 degrees, and then we multiply by the percentage multiplier. Now, if you are decreasing by 1.5%, that means you're left with 98.5%, which means your multiplier is 0.985. Think back to year 9 maths, learning about percentage multipliers. And that's happening once every minute, so it should just be raised to the power of 3. And you should be doing efficient mathematics like this. You shouldn't be working out what happens after 1 minute, then after 2 minutes, and then after 3 minutes. Your mathematics should be sophisticated enough to do this calculation using the power. So this gives you this, so 43.0 degrees to 3 SF. Part 2, you've got to generalise this. Write down an expression for the value of D at time n minutes after the drink is made. So the difference is 45 multiplied by the multiplier 0.985 raised to the power of n. And there we are. Now, part 3. Show that when D is less than 3, n must satisfy this inequality here, and hence find the least integer value of n for which D is less than 3. Now, I strongly advise in questions like this, highlight the different things that you are being asked to do, because people quite often do part of a question and then forget that there was more to actually do here. So, we're going to have a look at part 3 over here. D is less than 3, which tells me that 45 times 0.985 to the power n is less than 3. So what am I going to do with this? Well, I think what I'm going to do first of all is take logarithms of both sides, and you can see in the answer to the question log 10 has been used. So log to the base 10 of 45 times 0.985 to the power n is less than log to the base 10 of 3. You can already see we've got elements of the final answer incorporated here. Now, think about your logarithm rules. We've got log of a product here, so we can split this into log to the base 10 of 45 plus log to the base 10 of 0.985 to the power n, and this is less than log to the base 10 of 3. Now, let's subtract log to the base 10 45 from both sides. So log to the base 10, 0.985 to the n is less than log to the base 10 of 3, take away log to the base 10 45. And then on the left-hand side, we're going to apply another logarithm rule here and pull that n out to the front. So n multiplied by log to the base 10, 0.985 is less than log 3 minus log 45. And we'll divide by log to the base 10 of 0.985. Here is where you have to remember that this value, log to the base 10 of 0.985, is a negative number. Log of any number below 1 will always be a negative. And so you're dividing across an inequality by a negative, which means that we have to reverse the inequality sign. So n is then greater than log to the base 10, 3 minus log to the base 10, 45, all over log to the base 10, 0.985. Now, if you then evaluate the right-hand side here, n is greater than 179.179, and we're looking for the least integer value, so we've got to give n equals 180 as the least integer value. Now, let's have a look at the last part of the question, making some space here. The temperature difference can also be expressed as this. Now, this is a different formula to the one that we have used. We've used this, 45 times 0.985 to the n, and this is different, 45 times 10 to the negative kt, totally different formula. So we've got to use the value of d for 1 minute after the drink is made to calculate the value of k. Now, there are two parts to this question. Have you read it carefully? Can you see that there's a part here, and then there's a totally different part of the question over here? So what this wants us to do is to work out the value of d for 1 minute after the drink is made. Now, you can't do that with this new formula here because you don't know what k is. So you can use the old formula here, and we can say that d equals 45 multiplied by 0.985 to the power 1 after 1 minute. Now, what does that work out to be? That works out to be 44.325. We're now going to use the new formula. Now, the new formula is d equals 45 times 10 to the negative kt. And we've been asked to use this value here. So 44.325 is equal to 45 multiplied by 10 to the power of negative kt. But remember, t is 1, so negative k. So we're now using the second formula, and we're inputting information that we found from the first formula. So here, let's solve this to find out k. So divide by 45, 0.985 equals 10 to the minus k. And then negative k is log to the base 10 of 0.985, and then just simply write down your value of k, which is 0.006563 ... Now, I would store that in a calculator memory because we're probably going to have to use it, but I would then give a rounded answer, 656, to 3 significant figures. What next? Hence find the temperature difference 25 minutes after the drink is made. They want you to keep using the new formula here. There's no point using the old formula. They're looking and investigating a different formula. So d is equal to 45 multiplied by 10 to the power of negative k, which we now know is this value here we've stored in memory A, multiplied by the time, which is 25. So input that into your calculator carefully, and you should find you get an answer which is 30.840 ... so 30.8 to 3 significant figures.